Here's a problem with 5 separate, unrelated parts. Let's start with the first question, the inverse sine of radical 3 over 2. The definition is below. I'll pause while you read that. That is the meaning of the inverse sine of radical 3 over 2. So what do you do to find this unique number a? Well, this is where your unit circle knowledge comes in. If you know enough about the unit circle, and you sort of scroll through all the values in your head, you'll realize the answer is pi over 3. There's no real math procedure here, just the realization that, number one, pi over 3 is between negative pi over 2 and pi over 2, and the sine of pi over 3 is radical 3 over 2. So these problems essentially just become guessing problems because there's no, other than a calculator, real procedure to solve them. Let's go to the second of 5 questions. The inverse cosine of negative half, by definition, means this. I'll pause. And once again, all we do here is some form of guess and check where you think about all the arcs between 0 and pi and try to pick one, the only one, whose cosine is negative half. Your knowledge of the unit circle will eventually have you stumble across 2 pi over 3. 2 pi over 3 is correct because, first of all, it is between 0 and pi, and secondly, its cosine is negative 1/2. The same concept applies to the tangent. Here's the definition of the inverse tangent of 1. Eventually, your knowledge of the unit circle and a little bit of luck will guide you to pi over 4. The reason pi over 4 is the answer is because, first of all, it's between negative pi over 2 and pi over 2, and secondly, the tangent of pi over 4 is in fact 1. Let's move to the last 2 questions where we have nested functions, and these require a little bit more work. Let's look at this problem. The order of operations, or PEMDAS as it's often called, says that we have to work from the inside function outward. So I first have to try to address the inverse sine of negative 3/5. You may see it in red there. This is what that literally means, that there's some arc between negative pi over 2 and pi over 2 whose sine is that value. But the unit circle won't help you here like it did on previous inverse trigonometric function problems. Well, the unit circle will help, but not our favorite 16 points on the unit circle, because out of our favorite 16 points, there is no point whose y-coordinate is negative 3/5. That simply doesn't appear among our 16 favorites. So, what I like to do on these problems is draw a picture of the arc rather than actually trying to find it numerically. So what I've done here is I've picked an arc that has a terminal point whose y-coordinate is negative 3/5. And this negative or clockwise arc is the only value between negative pi over 2 and pi over 2 whose sine or y-coordinate is negative 3/5. Essentially, I've drawn a picture of the inverse sine of negative 3/5 rather than finding it algebraically. Now this quantity right here, I did work it out on a calculator just for fun, and I got negative 0.643, meaning the physical length of this arc is 0.643. Now you wouldn't know that because you'd be doing this without a calculator. But it's worth mentioning because it proves to us that that arc does exist. It does have a length. But we can't find it without a calculator, at least not algebraically. But good news, we're not just trying to find that. In fact, we're not really ever going to find that, but we are trying to find the cosine of that. And while I can't find that arc length directly without a calculator, I can still find the cosine of it. Because the cosine of that arc literally means the x-coordinate of the terminal point of that arc. And I know the terminal point of that arc. I know where it is. All I need to do now, watch the diagram, all I need to do now is find the x-coordinate of that terminal point. And in so doing, I will have found the cosine of that arc and hence answered the question. So how are we going to go about finding that x value? Well, luckily the terminal point is on the unit circle and therefore must obey this equation. And knowing the y-coordinate of that point will allow me to find the x-coordinate. Ugly algebra omitted. Try it yourself, hit pause if you'd like to. You will discover, however, that x is 4/5, or the x-coordinate of that point is 4/5. Therefore, 4/5 is the answer to this problem. Finally, let's go ahead and do the last of 5 problems here. It's worth noting that I have a function inside of a function multiplied by 2. So I'm going to start by working from the inside out and save my multiplication for last. First, I need to compute the sine of 4 pi over 3. If you know your unit circle well enough, you'll be able to find that. Next, we have to find the inverse cosine of that result. Here's the definition again. At this point, solving this inverse cosine, you may see it in green, just becomes once again a matter of knowing your unit circle and a little bit of luck. You'll eventually discover that that result is 5 pi over 6. By the way, you'll discover that because if you were to look at the entire unit circle, you would only find 2 points whose cosine is negative radical 3 over 2. I believe they're 5 pi over 6 and 7 pi over 6, but among those two, only 5 pi over 6 meets the criteria in the definition of being between 0 and pi. Finally, having saved my multiplication for last, as PEMDAS would indicate in this problem, I multiply by 2, and I'm done. And that completes the problem.